Alright, what'd you tell me? 25C. Yep. 25C. Equation of the line tangent to the graph of x at negative pi over 4. In order to graph tangent, I need two things. In order to do a tangent graph, I need two things. In order to do an equation of a tangent line, I need two things.
You need the derivative.
Before that, two things. And literally, in order to do equation of a tangent line.
Oh, point and slope.
Thank you. That's what I need. I need a point and a slope. Let's talk about my point first. F of negative pi over 4. Tangent of negative pi over 4.
-1.
By the way, that's going backwards on the unit circle. That's into here. Tangent would be negative. So if you know the tangent of pi over 4, which is 1, because that's these two over each other, and that means I'm negative here. Let's also know you're figuring out where they are, because then you can just do the sign. Alright. Now I need to talk about f prime of x. What's the derivative of tangent?
Secant squared x.
So f prime of negative pi over 4 is secant squared of negative pi over 4. By the way, in order to do this, I'm going to rewrite this as secant of negative pi over 4 quantity squared. So I'm going to do the secant of negative pi over 4 first, and then I'm going to square that answer. Well, secant is the reciprocal of what? Secant is the reciprocal of cosine. Cosine in this, the cosine of pi over 4, that's this number. And cosine in the fourth quadrant is positive. So my answer for this is the reciprocal of square root of 2 over 2, which is 2 over the square root of 2 squared, which is 4 over 2, which is just 2. So my slope is 2. My point was negative pi over 4, comma, negative 1. Y minus y plus 1 equals 2, parentheses x plus pi over 4. You all realize that the tangent line is different than the tangent of x, yeah? Tangent of x is a function, tangent of line is the equation of the line that touches the graph only once. It is the same word tangent, but it is different. Everyone okay with that? Alright, so let's talk about today, what we're doing today. So, today, hold on one. So the first thing that we're going to talk about is we're going to talk about implicit differentiation, which you've actually done before with polynomials. It's where it's not literally solved for y. It is where it's not literally solved for y. But I want to talk about the chart first that's up here on the paper. And it's just a tool to help you if you're like, yeah, this would help me out, great, use it. It does not, don't worry about it. What this tool is you'll notice that I've written sine, cosine, sine, cosine, sine, right? In order. Sine and cosine, sine and cosine 5 times, right? And the two middle ones, I have two are positive, the next two are negative, and the third one's positive. And the reason I did this is to help you out when we talk about derivatives and integration. Because if you write in this order, if you just remember this order and write in this order, what's the derivative of sine? Cosine, what's the derivative of cosine? Negative sine. What's the derivative of negative sine? Negative cosine, because the derivative of cosine is negative. The derivative of sine is cosine, but there's negative outside. And what's the derivative of negative cosine?
Sine.
Positive sine, because the derivative of cosine is negative, negative cancels out. So if this would help you to just memorize it, I can write this down and then I can look at it. Great. If not, don't worry about it. Just another way for you to memorize. I do not care how you memorize this. It's your choice. Just memorize. Well, let's talk about the very first example. The very first example I have up here says sine x plus 2 cosine 2y equals 1. Let's talk about the derivative of sine x. Cosine x. what's the derivative of 2 cosine 2y? How do you, or you, 2 what? Okay, so let's talk about what Emma just said here. Okay, Emma said 2 negative sine 2y. Now, Emma, why did you say 2 negative sine 2y? Okay, so the derivative of cosine is negative sine, so that's why you put this here. I totally agree with that. The 2 you said just hangs out, right? Okay, I totally agree to an extent of what she said. There is an issue of what I've written. Well, I'm going to talk about that in just a second. That's an issue, but it's not there yet.
It looks like you're subtracting.
Oh, it looks like I'm subtracting. What should I be doing? So do those parentheses matter right there? Hugely. And then I'm also going to do one other thing. Back up here, I'm going to put a parentheses around the 2y. And there's a reason I'm going to put a parentheses around that 2y. Because that 2y is my actual angle. And if you think about this, the 2y is not by itself. The y is not by itself. Nor is the y an x. If the y is not by itself and it's not an x, then guess what I have to use? Chain rule. Your outside is 2 cosine. Your inside is 2y. What's the derivative of the outside? We've already talked about that. She actually gave me, Emma gave me the derivative of the outside. 2 negative sine. But we haven't talked about the derivative of the inside. What's the derivative of the inside? Well, look.
2 dy dx.
Y2 dy dx.
So taking t dx of y.
Perfect. And taking the derivative of y with respect to x. It's not an x, but you have to have that dy dx attached to it. That's an implicit. So a couple things to remind you of. The moment it's not a plain old variable as the angle, you have to do chain rule. The moment it's not a plain old variable as the angle, you have to do chain rule. The moment it's a y, you have to do chain rule. So I have, this one just stayed, it was good. We've now done, that's my derivative of my inside. My derivative of the outside was 2 dy dx. So that's the blue piece. That's my blue piece. It's sitting over here. Equals. I'm going to clean this up a bit. So I have cosine. I'm going to combine this 2, this negative sign, and this 2, because it's all multiplication. That gives me what? -4. Now please note that what was inside the sign never changed. What was inside the angle never changed. That 2y never changed. And it shouldn't ever change. What's inside the angle never changes. That's stayed there. That's that chain rule piece. That never changes. Alright, what do I need to do? What am I solving for again? Solve for dy dx. So what am I going to do? Alright, move the cosine. Alright, so that should be 5. Cosine x over 4 sine 2y. Anybody know? I actually simplified something. What did I do? The negative on the top and the negative on the bottom, but there's all multiplication, so those can go away. That's what I did. You okay with that? Alright, I want you to try and start the number 2 without me, and then I'll jump in. Yes, ma'am.
Can you get my mom's message?
Alright, you're all ready? do you have 2 sine x minus sine, times negative sine y divided x plus 2 plus cosine y times 2 cosine x? It doesn't matter the order. Could I have the cosines first? Yeah. It doesn't matter the order because it's product rule. Okay, I'm going to clean this up a little bit. So what are you going to do next? You got to do what? Solve for
dy dx.
dy dx. So Gabriel, what do you want to do?
We're gonna subtract 2 cosine.
That works. Negative 2 cosine y cosine x. Come on. Totally. Totally. Like this? Yeah. Yeah. Yeah, I tend to, the moment my variable is not by itself, I tend to always put it in parentheses so you can see it, but you can do it right here too. Doesn't matter. That way if you're like, oh, there's my angle. That's what I don't have to have. There's my angle. Yeah. Tell you, parentheses. You all realize this gives you dy dx equals negative 2 cosine y cosine x over negative 2 sine y sine x. Right? What can cancel out this time? Negative 2. So I'm left with cosine y cosine x over sine y sine x. Everyone agree?
Can we simplify
Is it-
that
yeah.
further?
Yep.
U cotangent x times cotangent y.
Yep. Just an FYI, it's okay with you relieving the red. I prefer the black, but I will guarantee that on the AP exam, the black is going to be there and the red would not on a multiple choice. For your bonds, the red is fine. But I guarantee on a multiple choice, the black is going to be there, the red will not. Okay? There's one more that we're going to do. Last one we're doing. Find the equation of the tangent line at x cosine y equals 1 at the point 2, pi over 3. This will be why I said take out your own paper. Do that one. But there's not enough room. Finding the rule, product rule. So, first, derivative of the second. By the way, the derivative of the second, you have to use what? The derivative of cosine of y, you have to use chain rule because it's not a plain old x sitting right there. So the moment this is a y, the variable is a y inside a cosine, you better use chain rule. Outside is cosine, inside is y. Derivative of outside is negative sine. Derivative of inside is dy dx. So I have negative x sine y dy dx plus cosine y equals 0. Now I can subtract my cosine y and I can divide, but here's my question for you. What am I looking for? What's my answer supposed to be?
Equation.
An equation. Do you have to then actually solve right now for dy dx? Or could I plug in now and get me numbers to deal with instead of a functions? You can do it either way. You can solve for dy dx and then plug in numbers, or you can plug in numbers now. It is up to you. Both will work. But sometimes, some of you just like it easier for numbers, so I'm plugging my numbers in now. And then I'll solve for dy dx. Right? What's the sign of pi over 3 again? Yep. Which means that the sine is square root of 3 over 2, then the cosine is 1/2. Because that's the pair that goes together. So I have negative 2 square root of 3 over 2. Son! Yeah, we're talking about all sorts of stuff now, this.
But, sorry, what's the question?
It wasn't a question, I just want you to stop talking about everything else.
Okay, I'm sorry.
Thank you. I'll answer your question from now. What do I want to do next? I can see. What do I want to do next? There we go. What's next? People. You. Them. Augustine, Simran. Alex. One of you.
Oh, you divide by the radical. Negative.
Are you allowed to leave it as 1/2 over the square root? Nope. Nope. You can do 1 over 2 times 1 over square root of 3. And you can write that as 1 over 2 square root of 3. That's not what you said. You said 1 over 2 times the square root of 3. That's 1 over 2 times the square root of 3.
1 over
2 square root of 3. 2 times the quantity. 1 over the quantity.
I don't like this.
There, am I done?
No.
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 No, I can leave right over there.
That's the slope.
That's my slope. That's my slope. I have a point. There's my point. Alright. So, here's what I want you to do next. We're doing Sage and Scribe.